All right, so we're going to get started on lesson 5.1, first lesson in chapter 5, and that's going to begin with a lesson on the exponential properties. And you can find a list of those that we're going to talk about on page 330 in your textbook. So if you have your textbook open while you're listening to this video, it will help a lot when I start talking about the properties of these different exponents. A lot of this stuff's going to sound familiar, and so we're kind of just starting off basic and making sure you have those exponent rules intact. In number one, we start out with two exponential expressions. They're being multiplied together. They have the same base. So according to the product of powers, when you have a situation like this, you can take the base and just rewrite it, and then add those exponents together. So I'm going to rewrite that base, add those exponents together, and end up with 2 to the 8th. So when you plug that into your calculator, you would do the 2 and then the little caret symbol and the 8 and then hit enter, and it should pop up with 256. Okay, if you don't get that, then you may need to read your directions for the calculator on how to calculate these exponential expressions, but most calculators work that way with the caret key. All right, and this is called the product of powers. All right, if we go down to number 3, we start out with product of powers again. We have the same base, 4, and we're going to add those exponents together. Now they happen to be negative exponents, and so we end up with 4 to the negative 7th. And we don't generally, when we simplify something, when we're actually trying to find actually calculate the expression, we're not going to leave it like that. If you have a negative exponent, you have to make it positive by taking it and putting it, basically reciprocating it. So if you, in this case, we had 4 to the negative 7th was a numerator, because essentially we have this over 1. And so if we take that 4 to the negative 7th and flip it down into the denominator, it becomes positive. The exponent becomes positive. Then you would do the same thing. Take your calculator, and you can do 1 divided by, and then put 4 to the 7th in parentheses, and hit enter. Or you could just calculate 4 caret 7. If you do it that way, you'll just get a fraction like this. So it kind of depends on whether you want a fraction or you want a decimal. If you wanted a decimal from here, you would just go ahead and do that division problem. But this right here, the way we have it there is good. All right, so when we do that reciprocating, we call that the negative exponent. Okay, so that's the rule for that one. So we have product of powers, that's how we started it, and then negative exponent. All right, on number 4, we see that we have a exponential expression, 5 to the negative 2nd, and then it's raised to the 2nd power. So when we have a situation like that with one base, and it's raised to an exponent, and then the whole thing is raised again, we multiply the two exponents together. So this becomes negative 2 times positive 2. We end up with 5 to the negative 4th power. All right, that step is called power of powers, or power of a power. All right, but then you see that we have a negative exponent. We want to flip that into the denominator, because this is really over 1 right now, so we're going to put it in the denominator, which just leaves us with a 1 in the numerator, and then we end up with a positive exponent. If you do 5 caret 4 in your calculator, you'll end up with this fraction right here. Okay, and so then that second property is called the negative exponent. All right, number 5, we are going to use a property called the quotient of powers. That's quotient of powers, which makes sense since we're dealing with a division problem there. When we have that situation and the bases are the same, like they are right here, they're both 4, we rewrite the 4, and instead of adding the exponents like we did in number 1 and number 3, when you're dividing two exponential expressions, you're going to subtract the exponents. So it's -7 minus a -3, so you've got to pay attention to all those negative signs. 1 to the 4 to the -4th power. Again, we have a negative exponent, so we want to correct that by putting it into the denominator. And then when we figure out the 4th root, or I'm sorry, 4 times 4 to the 4th power, rather, we get 1 over 256. All right, and then in number 7, we're going to use the power of a quotient. So this is, quotient. And with this, the situation we find ourselves in here is that you have a fraction, you have a numerator and a denominator, and they're in parentheses, that whole fraction is in parentheses, and it is raised to an exponent. And so what we do here is we're going to take each of those pieces of the fraction and we're going to raise it to the third. Okay, so when you put that into your calculator, 2 caret 3, you'll get 8. 3 caret 3, actually you probably don't even need to use your calculator for that. You get 8 over 27. And so the property there is called the power of a quotient. We're going to use that same property again in number 8. Now we have a negative exponent, but the same rules apply. It's a little trickier, but not the initial step. We're going to apply the power of a quotient by raising the numerator and the denominator to the -3rd power. But now when we want to simplify this, we need to switch their places. So in other words, in order to make the 4 to the -3, 4 to the +3, I have to put it in the denominator. In order to take 5 to the -3rd and make it 5 to the +3rd, I have to put it up in the numerator. And then we'll end up with 125 over 64. Number 9, we have two numbers that are written in scientific notation, and we want to multiply those two numbers together. So this is just a decimal number times an exponential expression with 10 as the base, and we have two of those. And so you know those numbers are just, they could be written out with all their zeros in place, and those could be multiplied together. But it's easier just to multiply them together when they're already in scientific notation. So in order to do that, you're going to take the decimal portions here, the non-exponential portions, and you will multiply those together. And I'm just going to put that in parentheses there. And then we will multiply the exponential expressions together. So when we multiply those decimal portion, we get 13.42. And then when we multiply the exponential expressions, we are going to use the product of powers. The bases are the same. So this is like number 1 and number 3 up at the top. We're going to rewrite the base. We'll add the 5 and the 6 together to get 11. And we're almost done. You can remember back to scientific notation in Algebra 1. The number's only in scientific notation if the decimal has one number to the left of it. In this case, we've got two numbers to the left of the decimal, so we have to rewrite that 13.42 in scientific notation before we can move on. So we're going to kind of leave that 10 to the 11th alone for a moment. We're going to rewrite 13.42 as 1.342 times 10 to the first. So of course you've got to remember which direction you're going. If you are moving that decimal place over to the left, then that you're going to have to multiply by 10 to the first, a positive one. A good way to check yourself is to go back and take 1.342 and multiply it by 10 to the first, or just 10, and see if you get 13.42. If you do, you know that you went the right direction. That your exponent should be positive. Okay, the hardest thing to remember is whether, when you do this rewriting, is whether the exponent on the 10 is positive or negative. So it's just a little check for you. And then we need to go back in and take care of that 10 to the 11th. We can't just forget about it. But we don't want to leave it like that. We're going to simplify it. So in order to do that, we don't have Anything else to multiply the 1.342 by, so we're just going to rewrite it, times, rewrite that base, and then use the power, the product of powers, add those two exponents together, and we'll get 1.342 times 10 to the 12th for our final completely simplified answer. On 15, we're going to take that, that 3, and we're going, that's being raised to, and we're going to apply the power of a power. So this is like number 4 up above. You're going to raise the 7.2 to the third power, as well as the 10 to the negative third. We're going to raise that whole thing to the third power. So 7.2 caret 3, that's how we would enter this into our calculator. Will give us this number right here. And you can see right away that is not in scientific notation, so we're going to have to do some work at the end to get it in scientific notation. 10 to the negative third raised to the third power is, we're going to multiply those two together. Okay, so we're going to say 10 to the negative third times 3 gives us negative 9. And then I'm going to take care of this right here. I'm going to ignore the 10 to the negative 9th. I'm going to move this over. This time it has to go over 2 spots to the left. All right, and if it goes to the left, that means I write a base of 10 in, and I am going to raise it to the second power. So again, if I double check myself, that 10 to the second is really 100, right? So if I take 3.73248, multiply it by 100, I'm going to get what I started with up here. So I know that my exponent has the correct sign on it. All right, I can't forget about that 10 to the negative 9th, so I'm going to pull that down, and then we will rewrite the number portion, the decimal number portion of the number, and then multiply the 10 to the second times the 10 to the negative 9th together to get that for our final answer. So I know I don't have number 16 circled, but we really should look at that one. Or maybe it is circled on your worksheet. I'm not positive, but on mine it is. On the one on the screen it's not, so I'm not sure what yours looks like. I'm not sure which one I copied. But anyway, we need to look at it because it is a division problem, and so it works the same way as the number 9, the multiplication problem, except instead of multiplying, you're going to divide those numbers out. So you're going to take the decimal portion part and divide, and then you're going to take the exponent part and you're going to apply the rule for dividing exponents, which is rewrite the base. If the bases have to be the same, rewrite the base, and then you're going to subtract those exponents. So we're actually dividing out the decimal portions, which makes sense. I mean, we don't have anything else to do with that part. We get 6.6, which is great. That means that that part of the number is already in scientific notation, so we're not going to have to do any rewriting there. And then we're going to multiply that by 10 to the first. So we're going to go through the same thing with properties of exponents on the back here, but we're just going to be using mostly variables instead of numbers. The properties work the same way. If you have, in number 18, you have two exponential expressions. They both have a base of x. So we rewrite that, and then according to the power of quotient, which is the property we're using here, you're going to subtract those exponents to give you x to the fourth. In number 20, the power of a product we'll use first. So we're going to use power of a product, and in doing that, we will take that sixth that it's being raised to, and we're going to raise each of the pieces inside. All right, so it's not just s to the third raised to the sixth, it's also that whole number portion. So 3 to the second is no longer 3 to the second, it's 3 to the second raised to the sixth power, and then that's being multiplied by s to the third raised to the sixth power. And then from there, we're going to use the power of powers, x property, and that means that we have an exponential expression raised to an exponent, so we're going to multiply the two exponents together. All right, and then from here to further simplify that, we would, oh, that's supposed to be to the 12th, not to the 6th. Sorry, 2 times 6 is 12. So in our calculators, we'll do 3 caret 12, and that will give you this large number, and then s to the 18th for your final answer. And number 21, do something very similar to start it off. We'll use the power of products. We'll raise 4 to the 0 power to the negative 5th power. So 4 to the 0 is going to be raised to the negative 5th. And then w squared is also going to be raised to the negative 5th power. If you then apply the power of power, we're going to end up with 4 to the 0 times w to the negative 10th. All right, the zero exponent, the property of zero exponents says that anything raised to the 0 power is just the number 1. So anything, whether it's a number or an exponent, anytime you see a variable or a number raised to the 0 power, it's 1. So we end up with 1w to the negative 10th, and then we have to utilize the negative exponent because we are trying to simplify this as much as we possibly can. So we're going to end up putting that in the denominator, just leaving a 1 in the numerator, and that's our final simplified answer. Now, number 22, it looks a little bit different, but it's the same thing that we've been doing with product of powers, but they just have it organized a little bit, so it makes it a little bit harder to see. But really what we have going on here is y to the 4th times z squared times y to the negative 3rd times z to the negative 5th. They've got parentheses around those expressions, but we don't need them because everything is being multiplied together. When this happens, I mean, you can see that we have like terms here and here. They have the same base is what I mean. So we can rewrite the base and say if we're multiplying them together, then we're going to rewrite the base and add those exponents. So 4 plus a negative 3 is going to just end up with y of 1. All right. We'll do the same thing with our z's because they have the same base. We'll rewrite the z and we'll add their exponents. 2 plus a negative 5 will end up giving us a negative 3. So now I have a y to the first power times a z to the negative 3rd. They're being multiplied together, so they don't have to stay together, and in this case they're not going to. We're going to want to utilize the negative exponent because we need to get that z to the negative 3rd to the bottom to make it positive. And then that y stays up there in the numerator. They're not the same term, they're just being multiplied together, that's all. They're not being added together or subtracted. That would be a problem. But because they're just being multiplied together, we can move the 1 down into the denominator without hurting the other one. All right, and here it looks a little complicated in 27, but it is just a straight up quotient of powers. You're just dividing, and you're going to divide the things that are alike. So I could write all this out, but we can kind of just maybe see it in our heads here. We know that we're going to take 16 and divide it by 4. That'll give us 4. If we're dividing q to the 0 by q to the negative 3rd, we know that the rule says we're going to rewrite the base, and then we're going to subtract the exponents. So we have 0 minus a negative 3. So 0 minus a negative 3. And then that r, the bases are the same, so we're going to say r negative 6 minus that negative 7. So when we look through there and we change all those signs, we end up with 4 q to the 3rd and r to the first power. So this right here is using the quotient of powers, and we got our final answer. In 30, they ask for an expression for the surface area or the volume in terms of x. So in number 30, they give us the formula for the surface area of that sphere. They don't give us enough information for us to actually solve for the surface area, but you've got to pay attention to those directions. It just simply says to write an expression. It doesn't say solve for surface area. They just want us to take that x to the third, which is the radius, half of the circle is the radius, and they want us to plug that in for our radius up there in the formula and just write out the expression in terms of x, so that if we ever were given x, we could calculate the surface area then. So we're just rewriting it with that x to the, I'm sorry, x over 3, x divided by 3. So we're going to place that x to the third in parentheses because r is being squared. So not just that x portion, but the whole thing. So we've got to put the whole thing in parentheses and square it. When we do that, we raise that x to the second power, and the 3 also gets raised to the second power. Okay, that's the one of the properties that we did on the front page. We can still simplify that. So it'll end up being 4x squared pi. I'm just sort of rearranging things. If you have the pi first, that's okay. As a matter of fact, I actually I'll probably go ahead and write like that instead. So 4 pi x squared, and then that's going to be over that 9. Okay, now we can take and just like you would when you're pulling out coefficients, you can pull that 9 out, that 4 and that 9, and say it's 4/9 pi x squared. And that would be the simplest form, the easiest form to use. So now, if you were given x at any point, you could just stick it right in here to this formula and calculate the surface area. All right, in 33, they tell us we have 8,600 species of birds in the world. The mean number of birds per species is approximately 12 million. They want to know how many birds there are in the world, and they want our answer in scientific notation. So the easiest way to do this is to go ahead and write each of these numbers in scientific notation just from the very beginning. All right, so we know that 8.6 times 10 to the third is the same thing as 8,600. And we're going to have to multiply that, of course. This is our number of species. And then we're going to multiply that by the number of birds per species, which is this 12 million. So if we rewrite 12 million, I'm going to make it 1.2 times 10 to the 7th. So now it's easy just to plug in to our calculator 8.6 times 1.2. When I do that, I'll get 10.32. And then times 10 to the third at times 10 to the 7th. So I'm rewriting that base of 10, and I'm adding those exponents together, and I'm getting this number right here. So I sort of just skipped the step of actually writing out 8.6 times 1.2 times 10 to the third times 10 to the 7th, which I had done on the previous problems. I'm kind of just doing it on my head instead of actually writing that out. Again, 10.32 is not in scientific notation, so we're going to rewrite that into scientific notation. And we'll do that by moving that decimal place over one space, and then we have to say times 10 to the first. And then don't forget about that 10 to the 10th that was there. So final answer, 1.032 times 10 to the 11th birds.